The James Webb Space Telescope JWST has revealed indications suggesting anthropoid-like activity far beyond Earth, drawing us nearer to resolving the timeless inquiry of whether we are solitary in the cosmos. The quest for extraterrestrial existence has been a perennial theme throughout human civilization, motivating innumerable creative works and speculative ideas on the topic. Our inquisitiveness about our role in the universe and the chance of not being lone entities seems intrinsically embedded in us, fueling our yearning to find companionship, possibly even from outside entities' world. We are approaching the solutions to the questions we cherish. But are those answers genuinely what we desire, or is there a more profound motive at work? In 2021, JWST posed a compelling hypothetical scenario regarding our potential for future instrumentation. Might our telescopes detect artificial illumination on a planet like Proxima B? This exoplanet, the nearest to Earth, resides in the habitable region of our proximate stellar neighbor, Proxima Centauri, approximately 4.5 light-years distant. It was hypothesized that Proxima B could be tidally constrained, akin to our moon, meaning that one hemisphere of the planet would perpetually face its star. This premise led to the notion that a technologically advanced civilization on Proxima B might be capable of transferring warmth and electrical power from the planet's sunlit side to its dark side using photovoltaic arrays, which generate current from sunlight. A follow-up study co-written by Magnus Vingam and colleagues proposed that if Proxima B's daylight hemisphere were covered with solar cells, upcoming telescopes might perceive this activity. Now, in 2024, with enhancements in sensitivity and functionality that the JWST provides, it is feasible that the telescope could aid us in further examining the possibility of artificial light or habitable states on exoplanets such as Proxima B. This breakthrough could move humanity in a different direction, a major stride in its progression. Before delving into the ramifications of this finding, it is crucial to comprehend how such an accomplishment became feasible. The James Webb Space Telescope mission remains dedicated to probing the enigmas of Proxima B. What is Proxima B? A noteworthy research target. Throughout antiquity, humankind has persistently pursued answers to the most elemental inquiries regarding the cosmos, our being, and our fate. These profound, though challenging, questions have driven our curiosity since we attained consciousness. With the swift advancements in modern innovation, one wonders, are we any nearer to uncovering answers to these age-old riddles? A philosopher might contend that we remain in the infancy of our comprehension of the cosmos and ourselves, whereas astronomers would enjoy distributing the most recent cosmic revelations facilitated by their instruments and technologies. Such progress may frequently go unnoticed by the general populace. They signify monumental landmarks in human advancement. As we persist in our exploration, with the world effectively within our grasp, we are primed to investigate the universe in manners previously unimaginable. One of the principal methods by which we are investigating the cosmos is via technological devices like the JWST. This instrument, constructed upon human space exploration, is founded on addressing fundamental inquiries concerning our position in the cosmos. It has already started to furnish insight into the potential for evidence of life beyond our solar system by the recent discovery of plausible artificial illumination on a planet many light-years away, Proxima B, a promising indicator of alien life. Proxima B, also known as Proxima Centauri B, is a rocky exoplanet orbiting an M-type star. These worlds are commonly more massive than Earth, yet less massive than ice giants like Neptune or Uranus, which belong to a different group in the cosmos. While much is yet to be learned about Proxima B, this milestone represents a considerable leap forward in our continuous pursuit to grasp our place in the universe. The very first tentative evidence of exoplanets dates back to 1978. Although it only gained recognition or validation from the scientific community at the time. However, the only year in which the first bona fide detection of an exoplanet was verified, astonishing researchers and igniting further inquiry, was later. Since then, many additional exoplanets have been established, with one of the most noteworthy cases occurring in 2003. As of April 1, 2024, 5,653 exoplanets have been validated across 4,161 planetary systems, with 196 of those systems containing multiple planets. These pioneering revelations are largely related to M-type stars, also referred to as red dwarfs. Red dwarfs are diminutive stars on the main sequence of the Hertzsprung-Russell diagram, making them far more prevalent in the Milky Way than other star types. However, due to their low luminosity, observing them is more challenging than observing brighter stars. Red dwarfs are categorized and designated based on their temperature and dimensions. Typically called M dwarfs, these stars have temperatures of around 3,900 Kelvin, which confer distinct properties. Proxima B's mass is estimated to be approximately 1.07 times that of Earth. It remarkably completes an orbit around its star in just 11 point-to-Earth days compared to our 365 point-to-5-day orbit. This offers insight into the magnitude of its star, Proxima Centauri. The star itself is notably dim across the electromagnetic spectrum, emitting only 0.16% of the Sun's luminosity. In the visible band, its luminosity is even lower, emanating only about 0.056% of the light of the Sun. Over 85% of the energy it emits is in the form of infrared radiation, and it orbits at a separation of approximately 0.04856 astronomical units from its star. The discovery of Proxima B was disclosed in 2016, prompting curiosity about why this particular exoplanet has sparked such interest. One key reason is that Proxima B is the nearest known exoplanet to our Sun, situated just 4 light-years away. Despite the immense distance between us, by cosmic standards, it is comparatively brief. Proxima B belongs to the Alpha Centauri system, a triple-star arrangement. Although its host star has low luminosity, it continues to be a major attraction for astronomers. The Proxima Centauri system is one of the most luminous stars observable in the night sky, ranking just behind Sirius and Alpha Centauri in brightness. Perhaps the most captivating facet of Proxima B is its potential habitability. Positioned within the habitable region of its star, it presents possibilities that have driven astronomers to embark on missions to assess the star's full potential. This is where JWST plays an indispensable role. The telescope's scientific objectives include detecting light from the earliest stars and galaxies formed after the Big Bang, studying the formation and transformation of galaxies, interpreting the emergence of stars and planets, and exploring planetary systems and the origin of life. As JWST persists in its investigation of exoplanets like Proxima B, we edge ever closer to attaining these audacious aims. The search for life on other planets, specifically extraterrestrial intelligence, is a central goal in space exploration. The endeavor to capture signals from intelligent civilizations originates from humanity's innate curiosity, a drive to comprehend all that moves and none of it does. This search has frequently been compared to a cosmic scavenger hunt where we seek the land of gold or electromagnetic signals, potential murmurs from civilizations far beyond our current understanding. As we forge ahead in our search for extraterrestrial intelligence, the ramifications of detecting artificial light or other indicators of life on worlds like Proxima B are monumental. These findings would not only transform our comprehension of the cosmos, but could also redefine our perspective of humanity's role in the universe. The notion that humankind is not alone could alter everything from our self-perception to how we plan our future on Earth. If we were to detect evidence of intelligent life on another planet, it would be a monumental event in human history. Much like the moment we first walked on the moon, it would signify the dawn of a new era in cosmic exploration, one in which humanity is no longer the only conscious species in the universe. Could it be extraterrestrial metropolises? In the end, what lies ahead for the James Webb Telescope? The quest for extraterrestrial intelligence is about more than merely locating other civilizations. It requires discernment of our place in the larger cosmic narrative. It involves posing grand questions. How did the universe originate? Are there alternative forms of life? What does our future hold? These inquiries propel the work of scientists, astronomers, and explorers who are pushing the limits of our understanding. Ultimately, the search for life beyond Earth is about more than just locating other sentient beings. It is about unveiling the true nature of reality, the origins of living systems, and the potential for life to endure across the vast reaches of space. Every new revelation, no matter how minute, brings us one step closer to comprehending our own position in the universe. With the James Webb Space Telescope at the forefront, we are poised to achieve breakthroughs that will alter our perception of the cosmos for generations. As we persist in our investigation and broaden the boundaries of human understanding, we should remember that the expedition itself is as vital as the objective. Every remark, every innovation is a step forward in our comprehension of the universe and our place within it. The search for extraterrestrial life transcends mere answers. It is about the journey of discovery itself and the exhilaration of unveiling the unknown. So, as we stand on the verge of fresh insights about the cosmos, it is evident that the pursuit of knowledge is far from complete.